The next topic is 8.3, the reactions in the electrodes. Okay, the reactions in the electrodes. So what you can find about the things here is, see, you can consider the lead chloride. So lead chloride, this is going to dissociate into Pb2 plus 2Cl minus. Okay, so you are well familiar, right? Actually, in a electrochemical cell, in a electrolytic cell, so so there are two electrodes. One will be positive electrode, and the next one will be negative electrode. You know that there is anode as well as cathode. So the positive electrode, as you are very familiar, this is nothing but an anode, and this is nothing but a cathode. Okay, let's see what when a reaction happens, what shall happen. What is actually the process, or like what is actually happening? See, we know very well the negative charge will attract it towards a positive pole, and the positive charge will attract it towards a negative pole. Okay, so here actually the lead-2 plus ions. Okay, lead-2 plus ions. So this is going to be attracted towards the negative pole, and the Cl minus ions. So this is actually 2Cl minus. Okay, this is going to attract it towards a positive electron. And let's see what is going to happen. This Cl minus, how the Cl minus is forming. You know very well Cl, when it is accepting an electron, this is going to be Cl minus, right? Because the negative charge it occurs. It happens when an electron acceptance happens. So this 2Cl minus, and the Cl minus, when it is reaching to the anode, it will gives the electron to the anode. So the Cl minus, it gives that electron to the anode, and what will happen is Cl minus will change into Cl. Plus you can consider reaction, if you are writing, it is Cl minus. So Cl plus the electron minus 2Cl minus. So this is going to be Cl2 plus 2 electrons. Okay. So this is how the reaction is happening. And the next one is Pb2 plus, the lead-2 plus. See, when it is going to the negative electrode, the negative electrode is nothing but a cathode. Okay, negative electrode. Why the negative polarity is happening? Because this is going to have negative charges will be there. Electrons will be there on the surface of negative polarity will be there on the surface of cathode. So what should happen is, in the cathode, okay, I will write this reaction here, okay, in the anode side. So 2Cl minus gives Cl2 plus 2 electrons, okay. And in the cathode side, this Pb2 plus, when it is accepting 2 electrons, this is going to be lead. So on the surface of cathode, the leaded opposition will happen, okay, leaded opposition will happen. And through the anode, this chlorine gas, this is going to release. Chlorine gas will be releasing out through the anode. Okay, and through the cathode, leaded opposition will be happening. And okay, so this is the process it happens. So now I already wrote the reactions, right? Here in the anode, you can see the electrons are getting released. Electrons are getting released in the cathode. Okay, so electrons are getting accepted. Electrons are getting accepted in the cathode. So in the anode, what is loss of electrons? Nothing but, you remember, please remember this code. We have said in the previous class, okay, oil rig, that is O is oxidation, is loss of electrons. Reduction is gain of electrons. Okay. Oxidation is loss of electrons, and reduction is gain of electrons. You can very well see here. Here actually the electron is losing, right? The electron is losing here. That is very evident and very clear. But on the other hand, electron is accepting here. In the cathode side, electron is accepting here. So here this is nothing but the reduction. Okay. So you are very well, this is nothing but the reduction. Okay, and here it is since it is losing electrons, so in the anode, you know, this is nothing but oxidation. Okay, so oxidation as well as reduction happens whenever there is a electrochemical reactions happen. Okay, and we will see further more examples. Consider another case, you know, like a concentrated solution. See, NaCl. Concentrated NaCl solution. See, you know what is concentrated means, right? Concentrated means, you know, it also contain water content. So water content, you know, see, if you are taking a beaker, you consider, you know, you are taking a beaker. So, you know, H2O plus, you know, this also contain NaCl. So, NaCl, as you are aware, this is going to ionize us into Na plus Cl minus ion, right? And water, that is also going to, though in a weakly manner, that is also going to ionize us into H plus and OH minus ions. Okay, H plus and OH minus ions. Okay, so for our easiness, we can do one thing. We can list the cations and the anions separately. Okay, so the cations are H plus and Na plus. The anions are Cl minus and OH minus. Okay, Cl minus and OH minus. So let's see what is going to happen when there is an electrolysis of sodium chloride. Not molten, concentrated solution of sodium chloride is happening. So the same way we can write the process again. So this is actually, you know, this is actually and positive, and so this is actually a negative electrode. So you can see the, you know, there is a possibility that, you know, two negative ions will pass towards the positive electrode. Positive electrode, as you are well aware, that is nothing but an anode. So what are the negative ions? In this, negative ions are Cl minus and OH minus. Okay, and towards the negative electrode, so obviously there is a H plus and the Na plus will be passing. So the negative electrode is actually cathode. Okay, and so here in the anode, what shall happen is, see, two ions are there, right? Cl minus and OH minus. When it is a concentrated solutions, obviously the amount of Na plus and Cl minus will be more in the solution. Okay, so the Cl minus in the anode, Cl minus, you know, when it is reaching the anode, so that will changes into Cl2 plus, you know, it will releases 2 electrons. Okay, so this is going to happen in the anode. And in the cathode, and you know, like see, cathode, you know, there are 2 ions, H plus and Na plus ions. When you see the electrochemical series, sodium ions is little more reactive than H plus. Obviously, sodium will try to remain in the solution, not on the, it will not come and deposit on the cathode. Obviously, you know, H plus ions, that is the one which is going to have preferential preference. So H plus will go to the cathode, and once it is reaching to the cathode, okay, so the cathode, you know, H plus ions, we can write the reaction in this way. So 2 H plus ions plus 2 electrode, so this will go to H2. Okay, this is going to be H2, and hydrogen gas, it will be passing from cathode. So in a concentrated solution of you know, sodium chloride, the possibilities are, you know, from the anode, okay, so chlorine gas will be passing out. From the cathode, hydrogen gas will be passing out. Okay, and if you see in between, what is remaining here? So this OH minus ion in the cathode, of course, you know, hydrogen is going, and so sodium Na plus is remaining. What is remaining is actually it is nothing but, you know, I will write here for easiness. What is remaining is Na plus is remaining, and in the anode, yeah, chlorine gas it has gone, right? Chlorine gas it has gone. OH minus is remaining. So OH minus and Na plus, obviously positive and negative charges it can easily bind. So it is going to, it will bind into sodium hydroxide. Okay. So this is only going to happen. Sodium hydroxide is sodium hydroxide gas. That will, sodium hydroxide. The solution it is going to remain alkaline. It is going to be very alkaline. You know very well about sodium hydroxide. It is a translucent solid. It is alkali. It is one of the very good alkali, caustic soda, which we use commonly for the purpose of making soaps and other commodities. Okay. And hydrogen, it is a very sound gas. Please don't play with the hydrogen. It is a very exponential gas. Chlorine, it is actually very corrosive gas. If you get it, you will be, you will be coughing like anything. So this is it about electrolysis of concentrated sodium chloride. Okay. So we will consider what can happen when there is if the solution is a dilute. Okay, you think that you are taking a dilute solution of sodium chloride. See, the solution of sodium chloride, if it is a dilute, okay, obviously it has a sodium chloride content as well as the content of water, right? So, but here remember one thing: the sodium chloride concentration. That means Na plus and Cl minus ion concentration, that is going to be less, right? The proportion is less and the amount is also going to be less. So what I can understand, what I can do from this is, okay, see, the same way, very well, the cations are, if you check the cations, Na plus and H plus, anions, OH minus anion and Cl minus anion, okay, and so, when there is a electrolysis are happening, when the electrolysis is happening, okay. So obviously same like previous situation, like Na plus ions and H plus ions, it will go to the negative electrode. Negative electrode is nothing but cations will go to cathode. Yeah. So this is nothing but cathode. And there are two ions are there. You know very well that that is one is OH minus. And the next one is Cl minus. So both will go to the positive electrode. Positive electrode are nothing but anode. It goes to the anode. So it goes to the anode, and this these ions Na plus and H plus ions, it will come to the cathode. So let's see what will happen. See the Na plus and H plus again. You know very well that Na plus, once you see the electrochemical series, okay, you can see the electrochemical series, and the Na plus ions, that is more reactive than H plus, so obviously it will remain in the solution. So H plus will be, what shall happen in the cathode is, H plus, obviously it will accept electron and 2H plus 2 electrons, so it will form H2 gas, hydrogen gas. In the anode, which is a positive electrode, there are two ions, OH minus and Cl minus, but see here one thing, OH minus ion concentration is higher than Cl minus ion concentration. So the reduction, oxidation of OH minus will take place in preference to Cl minus in such a way that, OH minus, so this is going to be, so it is going to be 4 OH minus, so it is going to have 4 electrons plus, then how much oxygen? It is going to be oxygen plus 2 H2O. Okay, so 2 H2O. So this is the reaction it is going to take place in the anode. Okay, so what is remaining in the solution? What is remaining in the solution is, see, through the anode, okay, you can see through the anode, the oxygen gas, it is going to get outside. It will go out. Through the cathode, the hydrogen gas, which is explosive, that will be releasing through the cathode. So the end products are Okay, the end products are, like end products are hydrogen and oxygen. Okay, the end products are nothing but hydrogen and oxygen, and this is the end products of electrolysis of sodium chloride. Now, if you check the same way, and you can write any products if it is a molten, for example, magnesium bromide. Okay, you think that you are taking a molten magnesium bromide, so this is going to dissociate into Mg2 plus plus 2 Br minus. Okay, Mg2 plus plus 2 Br minus, and in the anode, so what shall happen is, in the anode, Br minus is there, right? So 2 Br minus gives Br2 plus 2 electrons. So this is going to happen in the anode, and in the cathode, so Mg2 plus Mg2 plus 2 electrons. So this is going to form Mg. So the end products are nothing but a bromine. Through the anode, bromine vapor will come out. Through the cathode, easily, the magnesium metal will be depositing in the cathode. You can just check it up. The easiest way is, any salt, you take any salt. See, for example, let it be potassium chloride. You just check it, you just split it K plus plus Cl minus. So from that, easy for you to find what is going to be the product, which product it will come. You just need to split it and check what ions, which ions are proportionally present in it, and those ions, that will be the one which will be depositing in the anode and cathode, right? Okay.